In today's video, we're going to be taking a look at 3 problems, real ACT problems, that deal with using exponents. We're also going to do a mini lesson on scientific notation. Let's take a look. For this first problem, we're going to need to look at a couple of key rules of exponents. The first rule of exponents that I'm going to show you is this one. So I would call this rule 1 for this problem, which is if you have the same base and you're raising each base to an exponent and you're multiplying those together, the rule states that you add the exponents. So in this case, it would be a plus b as the new exponent. The second rule is when you have a base raised to an exponent and you raise that entire thing to another exponent, the rule is you're multiplying those exponents together. So in this problem, we are going to look at rule 2 because we have a x to the 4th, that whole entire thing raised to the 6th power. So this is the rule we're going to use, which means all we're going to do is multiply the 4 and the 6 together. And we end up with x to the 24. That is going to be G as our answer. If you thought about rule 1, that would give you answer F. So if the problem was x to the 4th times x to the 6th, it would be F. But since we have the parentheses there, we're raising the entire term x to the 4th to the 6th power. It's going to give us G. J and K have 6's as coefficients. That doesn't make much sense in this problem. And H, I think H might be 4 raised to the power of 6, which isn't one of the rules. In this second problem, we're going to take a look at what happens when you have numbers raised to powers and then looking at order of operations here. So one good approach to this problem would be to recognize that 9 raised to the 1/2 power is equivalent to the positive square root of 9. Same as 16. So this is probably going to be your fastest approach. So if you look at the positive square root of 9, that equals 3. And if you look at the positive square root of 16, that of course equals 4. So this problem then becomes 3 plus 4 squared. And then if you consider order of operations here, you need to complete the addition in parentheses first before you square it. So that becomes 3 plus 4 is 7. And 7 times 7 is 49. So the answer here is C, 49. Looking at the incorrect answers, if you look at the incorrect answer A, that would be 3 plus 4, so it's just before it's squared would be A, so that would indicate that you didn't complete the problem if you answered A. For B, I think B is kind of a more common mistake. I'm going to show you what the mistake would be for part B. This is the thing I would suggest just being really careful about, is the mistake here would be to kind of distribute this 2 to both. That doesn't work because your order of operations is incorrect. So if you were to think of it that way, you would get like 9 raised to the 1/2 squared, which is just 9, plus 16 raised to the 1/2 squared, which is just 16. But that's not correct because if you think about squaring this, it really is 9 to the 1/2 plus 16 to the 1/2, and we got to repeat that, right? So just remember your rules of exponents and your order of operations. This would be a FOIL type situation. So that's why B is incorrect. I think those A and B would be the common incorrect answers here. So the correct answer again is C, 49. One final comment on this problem would be if you like using your calculator, you could certainly use your calculator to solve this problem. It's just a question of whether or not you want to take the time to type it in. So as long as you type it in correctly, I'm showing you here how that would happen, you will get the correct answer. Just be really careful with your parentheses and with your powers. And instead of 1/2, you can absolutely put 0.5 in your calculator. So as you can see here, that gives you the correct answer. For today's mini lesson, we need to take a look at scientific notation. What scientific notation is basically a standard way of expressing a number that's either really, really big or really, really small. As you can see, scientific notation can basically be written as m, a number m, times 10 to the n. M is a number between 1 and 10. That is the standard form. Let's take a look at an example involving a really small number. So you can see here we have 0.00054. That is a really small number. If we want to rewrite that in scientific notation, we need to take the decimal point and move it over to the right as many times as we need in order to get that 5 to the left of the decimal point. Let's see how many times that is. So it's going to be 1, 2, 3, 4. So then we're going to rewrite this in standard scientific notation by writing 5.4 times 10 to the negative 4. The reason why it's negative is because that means it's a really small number. It's really the same thing as saying it's 5.4 divided by 10 to the 4th, which is a really small number. Let's take a look next at a really big number and write that in scientific notation. So here we have 6,750,000. So what we're going to need to do is move our decimal place, which is kind of hiding or by default after the whole number, the last 0. So we're going to move that all the way over until it's just to the right of the 6. So let's see how many times we do that. 1, 2, 3, 4, 5, 6. Okay, so let's rewrite this then as 6.75. Since we moved it over 6 places, it's going to be times 10 to the 6th. So with really big numbers, you're going to have a positive exponent, and with really small numbers, you're going to have a negative exponent. And as long as you just have one number between 1 and 10 to the left of the decimal, that's scientific notation. That's your mini lesson. Now let's take a look at our final problem. This third problem involves some rules of exponents along with scientific notation. There are many approaches to solve this kind of problem, and I encourage you to use whatever works for you. I'm going to show you a way that's basically sticking with good old school scientific notation, and we're going to be able to compare sort of apples to apples on each side of the equation, and we're going to be able to do some canceling as well. So first I'd like to group the 4.25 and the 6, and then I'd like to group the 10s on the left-hand side. So I'm going to just write 4.25 times 6, and then I'm going to write the 10s. Now, once we rewrite this, you're going to notice that the rule we talked about in the first problem is going to apply here to these 10s. So first, let's take care of the 4.25 times 6. If you put that in your calculator, it's 25.5. And then for the 10s, since we have the same base and we're multiplying them together, we are going to add our exponents. So the exponent just becomes 2c plus 4 plus 7. And then a quick rewrite there is going to give us 10 to the 2c plus 11. Okay? And that still equals 255. Now at this point, you do have a couple of options. I'm going to change the 25.5 into scientific notation. 25.5, if we move this decimal point over 1 to the left, that's going to give us 2.55 times 10 to the 1st. Similarly, with the 255 on the right-hand side, that's going to be 2.55 times 10 squared, because the decimal point on that 255 is just to the right of that second 5. If we move it over per scientific notation rules, we're moving it over twice. And then I'm just going to copy my 10. And then for the final part of this problem, we're going to combine our 10s on this side. We have our 2.55 on both sides. That's going to give us a really nice cancel. So this one's going to be 10 to the 2c plus 11, and then I'm going to add the 1. And then on the right-hand side, I'm just going to rewrite it here. And we'll make this a 12 in a second. But as you can see, there's a 2.55 on both sides. Those are going to cancel. And what you're left with is 10 raised to the 2c plus 12 on the right, and 10 squared on the left, and 10 squared on the right. So now we can just say, all right, our exponents must equal each other since our bases are the same. So just let's set them equal to each other. 2c plus 12 equals 2. And then solve the problem, move the 12 over. You get 2c equals 2 minus 12, which is negative 10. Divide both sides by 2, and you get c equals negative 5. And if you look at your answer choices, that is choice H. Thanks for watching. Don't forget to subscribe.